Assalamualaikum warahmatullahi wabarakatuh. We are in group 5. We'll talk about the growth of population in Ethiopia from 2000 until 2019. Let's start with the introduction of Ethiopia. So first of all, Ethiopia is located in the Horn of Africa, which means by it is located in the peninsula region of Africa. Besides that, Ethiopia is sharing border with Eritrea, Somalia, Sudan, South Sudan, Djibouti, and Kenya. Next, the capital city of Ethiopia is called Addis Ababa, and the current president of Ethiopia 2025 is Haile Selassie.
Okay, first of all, this is Ethiopia population statistic. That the data was obtained from Ethiopia population statistic, where we observe the number of populations from year 2000 to 2019. According to the data tabulated in table 1, the number of populations continue to rise from year to year. Okay, to find the particular solutions of differential equations for growth in Ethiopia from year 2000 to 2019, we use the multiplication model that can be written as dp over dt equal to kp, and where p is the total number of the populations present at time t, and k is a constant of proportionality. So to calculate the number of populations using the particular solutions, or you can say the multiplication model, and firstly we solve it by using the approach of separable variable by first separating the variables p and t, and then we integrate both sides of the equations, and it will be ln p equal to kt plus c, and we can add the exponential to both sides, and then we know that when e power of ln is equal to 1, so it gives p equal to e power of kt times e power of c. Okay, so the general solution can be p equal to plus minus e power of c and e power of kt. So we can let a to the plus minus e power of c, and it can be simplified to be p equal to a e power of kt. Okay, so next, using the initial condition t equal to 0 and the number of populations p from the year 2000, we can use the data to put inside the general solutions, and we can get the value of a. Next, we also find the value of the constant k by using t equal to 1 and the number of populations at the year 2001, and we can use the data and put inside the general solution, and we can get the value of k that is equal to 0.0288, and the particular solutions now becomes p equal to 66224804 exponentials power of 0.0288 times t. Okay, so this is table 2 after we calculate the particular solutions from all years, and we examined and found that the calculated and actual numbers of people are slightly different and increase rapidly, and when we compare the estimated numbers to the actual values, we can see that there are variations. As a result, we believe that multiple factors contribute to this divergence, which will be discussed in next slide.
Let's take a look at the graph of population of Ethiopia from 2000 until 2019. In my right side, they are the actual population data that we collected, while in my left side, they are the estimated population data that we calculated by using the first order differential equation. As you can see, there are some differences of the shape of the graph. It is due to the some environmental factors that happen in the country. However, due to these differences, we can identify the percentage of error of the graph. The percentage of error are between range of 0.01% until 2.2%, which is in a low range. This low range shows that Ethiopia are taking care of the population wisely and systematically.
Okay, next we calculate the future and the past value of the number of populations in Ethiopia, and for the future records we use the t equal to 20 at year 2020, and the past records number of people in Ethiopia we set t equal to -10 that at year 1990. So we use the general solutions that we get and put the number of t in the general solutions, and we can get the value of the future and the past value of the people in Ethiopia. Okay, next, as we can see, the actual value of the number of populations in Ethiopia also increases, but not in the same manner as the particular solution. So this is why there is a data deviations when comparing the graph of the actual and estimated number of people in Ethiopia from 2000 to 2019. So we use the multiplication model, the reasons for the inaccuracy for our results. Okay. First of all, it is because high rate birth and declining mortality rate has been the major factors that contributed to the high growth rates of populations in Ethiopia. Fertility has been on the rise over the past decades, and there has also been a slow but persistent decline in mortality despite war and natural disasters. Last but not least, the impact of rapid population growth on economic development could be observed in terms of productivity changes in the economic sectors. For example, in the agriculture sector, particularly in crop productions, the effect of population growth on productivity has been negative, and measures taken to reverse it has been ineffective.
So for the fourth question, it is what has affected the population growth in the past? Well, one of the main causes of Ethiopia's population growth has been the country's consistently high fertility rate. In the past, especially in rural regions, Ethiopian women typically had 4 to 7 children. This high birth rate has been caused by several factors, including cultural traditions, early marriage, and financial gain by having children to do domestic and agriculture chores. Other than that, another main cause of Ethiopia's population growth is the lack of education, especially among women and girls. Reproductive behavior and education are closely related. Research demonstrates that fertility rates tend to decrease as the education levels grow. Back then, Ethiopia had a lack of family planning information, resulting from restricted access to education. Due to economic pressures and cultural norms that prioritize childbirth, women with little to no education are more likely to have larger families. So for the fifth question, it is what do you think might affect the population growth in the future? And so in my opinion, I think that the future population growth of Ethiopia is expected to be influenced by the improved healthcare. As we know, Ethiopia has gone through many and different types of illnesses such as malaria and tuberculosis. And so right now with the advancements of technology, more people will more likely to survive these illnesses, and children are expected to grow up to become adults. Since more people are living long and healthier lives, it is anticipated that the population will grow steadily. The future population growth of Ethiopia might also be impacted by the economic growth. Economic development can also result in increased employment and higher living standards, all of which can lower child mortality and increase life expectancy. The population as a whole keeps increasing as more children live and people live longer. Furthermore, growth in economic frequently encourages infrastructure and healthcare investments, which facilitates access to services that enhance population health and well-being for both urban and rural residents.
The conclusion of this one is, first of all, we were able to differentiate the values of the actual population and the estimated population by using the first order differential equation. Next, we were also able to determine the number of population of Ethiopia for the future by using the first order differential equation. And last but not least, we were able to analyze some of the reasons that caused the estimated data are different from the actual. So that's all from us from Group 5. Thank you.
I would like to give a brief explanation on the application of trapezoidal rule to find the area under a curve using Excel. So first of all, the x value here, we can just plug in our upper limit, which here is 3, and the upper limit is 5.2, and this n is the amount of subintervals, and this h is the height of the trapezium, which is upper limit minus lower limit over n. So next, we have to take the first value of x and add it with the h, which is delta x, and we can just drag this column until we find the value of our upper limit, which is 5.2. For the function, we can just put in our integrand and then replace the value of x, replace x with the column here in the x value. For the coefficient, just take all of the coefficient 1 until the final one, and just times it with the function, so we can just get all of the coefficient, and then we can just use the formula sum all of this coefficient times 0.5 times this h value, and then we can get the total sum of the area. So the exact same thing can be done for it. 10 subintervals, we just copy the exact same formula, the exact same value of upper limit and lower limit, except for the subinterval. This process is still the exact same. It is the value of the first x value, just add it with h, and then just drag it until we receive our upper boundary, which is 5.2. This is still the same. We just take the value of our integrand and all of this x value. For the coefficient of x, we will also have to times it as usual, and thus you can also just get the total sum, which is 12.97261434.
To continue task 2, this is question 2, where the question states that the equation 8 minus sine squared 3x plus 1 minus 1 plus x cubed to the power of 2 is equals to pi has a root at x between 0 and 2.5. use Newton-Raphson method to estimate the root correct to 5 decimal places. So to solve this question, we use the equation xi plus 1 equals to xi minus fxi over f prime xi, where I is the number of iterations. So we chose the initial approximation as 1 since the root x is between 0 and 2.5. So by using functions in Excel, we just type our function, and then we found out that the repeating result is at the second and the third iteration, where the value of x is 1.01863 in 5 decimal places. So this is the approximated root. So when we compare the approximated value with the actual root that we plot at when we plot a graph at Desmos, we found out that the value is the same, which is 1.01836. So we can conclude that the approximation of root at x between 0 and 2.5 is 1.01863 in 5 decimal places. That's all from us. Thank you.